Greetings everybody, we are Cure Crew. I am Yasira Muhammad and we're here today to present the idea of our research paper, Neural Decoding of Speech as Intuitive Paradigm of AI and Sensor Communication. To start with, there are certain groups of people in the world that have disabilities that may make their life much more difficult, and the aim of our paper or our research is to solve the problem of a certain population, which is the mute population. So the studies established or the studies estimated that the population of the deaf people is around like 70 million people all over the world. But not all deaf are mute. Deaf people actually have the ability to make voices, but they can't use language because in order to use language, they have to hear themselves, hear their pronunciation, and they lack the ability of this. So they just choose to use alternative ways in communication, such as sign language and etc. So let's get to the problem. What makes a person speechless? Or what makes the speech disorder? So we all know that the brain is the one in control. It just controls all our actions, emotions, and movements. And so there are certain regions in the brain that are responsible for language, whether it is spoken or written. These areas are the Broca's area and the Vernix area. The Broca's area is located in the frontal lobe of the brain, and the Vernix area is located in the temporal lobe. Insults to this area may result in speech disorders like stuttering or aphasia. Well, aphasia can occur suddenly due to a stroke or an injury in the head. It can also develop gradually as a result of a growing brain tumor or something. There are also other types of speech disorders, such as aphonia, which occurs due to emotional or psychological stress. Or dysarthris, that is mainly about a weakness in the muscles used for speaking. Going back to December 2020, a group of scientists, including Dr. Edward Chang in Pennsylvania University, published a paper titled Neural Decoding of Imagined Speech and Visual Imagery as Intuitive Paradigms for BCI Communication. This paper introduces a device in the size of a chip. It's inserted inside the brain and it can read the signal or the electrical signals between the nerves and send them to an AI bot. This AI bot decodes them and produces spoken language.
Good morning, I am Narada and now I'm going to talk about our solution. So we will make a sensor that will be programmed to detect the signals and encryptions that Dr. Edward Chang decodes them. The sensor will send it to an AI. This AI will convert these encryptions and signals to the letters and words that someone wants us to say and then utter them.
Hello, I'm Hanin and I'm gonna talk about the methods. First, we should know about two places, Broca's area and Wernicke's area. These places are the regions in the brain which are responsible for speaking process. When you want to say something, they send the specific signals for what you want to say to the larynx and the tongue. As we have known from the research of Dr. Edward Chang that every letter has its own specific signal. So, if there is a disorder in Broca's area or Wernicke's area, there will be a problem in the speaking process. So we have decided to solve this problem by using brain signal sensor, which is Neuro Sky Mind Wave EEG, and an AI, which is programmed by entering the signals of the brain that have been mentioned before. So when a deaf person wants to say something, the sensor will pick up the signals from Broca's area and Wernicke's area and transfer them to the AI, which will decode them and translate them into understandable words. There is one difference between our idea and Dr. Edward Chang's experiment, which can be a modification. which is that our sensor will be on the skin, not inside the brain, so the deaf person won't need a surgery. That is all about the method. Goodbye.